Ready for our big finish in chapter 7? Here we go. 2 more mechanisms. We're going to do the reaction with hydroboration protonolysis. Hey, protonolysis is a word we saw earlier. Oh boy. Let's just. As opposed to dissolving sodium reaction. Top one's pretty straightforward. We've attacked one of those 2 atoms before, H or B, B being boron 2.0, hydrogen 2.1. We're attacking boron. And you usually say, bring the hydrogen back to the more substituted carbon. Well, ladies and gentlemen, alkyne that's internal doesn't have a more substituted carbon. So it doesn't matter which carbon you come back to. I don't care. Pick one right there. Only one intermediate is needed here. Here it is. Still have 1 pi. You got a new H on the more, well, not more or less, and BH2. And then protonolysis is here. HOAC. Carbon gets the H. OAC minus leaves. And you're done. That's it. You're curious about the other 2 things? BH2 cation, OAC anion. They will probably combine, but it's side reaction. I don't care. I don't need to see them, okay? Don't need to see. Don't need to see these. Okay? Side products. And you don't need to see that they probably come back together and make a bond. It's okay. So not a terrible mechanism, right? And what kind of alkene did I make that way? Cis or trans? Cis. Next one's going to make trans. How many valence electrons does sodium metal have? You got to look over there. Yeah, it's in the first column. Has 1 valence electron. There's a name for a species that has an unpaired electron. Sodium radical. Radical has unpaired electron. Unpaired electron. That's very reactive. Trying to move this down a little bit. Worked out pretty well. So we don't have an arrow for that. But some of you read ahead a little bit. We have something that looks like an arrow, but it represents 1 electron moving instead of 2. Yeah, I knew she was on track when she said half an arrow, but half of a head on an arrow. How's that? You like it? But it looks more like you know, the thing that the fish bites. Anyway, I'll write it and maybe you'll see it now. Doesn't that look like a fish hook? It's a hook. Okay, so Na dot, that's a hook. Hook equals 1 electron moving. So a lot of extra stuff here, okay? And that would create an octet violation right there. You'd have 9 electrons. So we compensate by booting one of the electrons off there, and another electron forms a pair. Do you agree two hooks coming together is going to be a pair of electrons on that atom? Please agree, because that's exactly what happens. 2 hooks ending in the same place is a lone pair. Sorry, 2 hooks ending on the same atom is a lone pair. Gotta be careful I say things. 2 hooks meeting on the same atom is a lone pair. I'll put it black. Now, what about the other carbon? How many electrons does it have on it? 1. That's called a radical. And this one's called an anion. When I'm finished, it's going to be called an anion because that carbon has a minus charge. You better show that. I want to point out that's the conjugate. These are notes again. Conjugate base of an alkene. That anion is the conjugate base of an alkene. So what kind of reaction is going to make the anion into an alkene that has its H? Acid base, that's what I wanted to hear. I don't have hydride. I have to use what's available. Something with a pKa less than 45 has to be available. How do I know that? Because 45 is the product. The reactant has to be less than 45, and what is it? 40. It's an amine. I know it's not an amine, but it's the equivalent of an amine. Acid base. That's NH3. I just drew it so it shows one of its bonds. That's all. So the radical anion is now just a radical that needs to become an anion. So I can do the same thing. Can I move this whole comment section? Apparently not. I think that's not. Wow. I can live with that. Okay. I need my comment box out of the way, that's all. How am I going to make that into this? Where can I get an extra electron? Yeah. If it's solvent, by definition, that makes it excess. So you have as much sodium as you want, and you have as much ammonia as you want. That's what NH3 is. So sodium number 2 hooks up with the radical and makes a lone pair. And then NH3 number 2 does an acid-base reaction. And you are done. I mean, done for the test. That's the last topic on our test. And there you have it.